We're going to talk about titrations, and titrations are based on neutralization. So this is when you combine an acidic solution and a basic solution so that the H plus and the OH minus concentration are equal. So basically acid plus base yields what we call a salt and water. Now a salt can be any ionic compound. Remember that ionic compounds are electrolytes because they ionize when you put them into water. So you guys are familiar with neutralization mostly because you might see like antacids, Tums. You know, if you have heartburn or something like that, you take the Tums and it will neutralize the acid in your stomach. So the learning target, we got, we're going to use this M1V1 equals M2V2 formula to solve the titrations, and we're going to interpret titration graphs, okay? And of course the honors, we got the honors target here using stoichiometry. Alright, now a titration is a laboratory method that determines the concentration of a solution. So we have a concentration that we know, and we use stoichiometry. A couple of terms. Equivalence point is where you have neutralization, H plus equals OH minus. The end point is where you see a color change with an indicator. And we'll look at a couple of these. So the end point and the equivalence point should be really, really close. Alright, so we have our example here. Now this is on your practice paper that you got. So with 89.2 milliliters of 0.765 molar sodium hydroxide, it's going to neutralize 50 milliliters of HCl. What is the concentration of acid? Now the formula looks like this. NaOH plus HCl, we get salt and water. So we are going to use M1V1 equals M2V2. So make sure that your 89.2 milliliters and your 0.76 molar goes together. Oops, sorry. And make sure that 50 goes with our unknown concentration. And so when you solve this, you get a concentration of 1.36 molar. Now you have these titration curves on your sheet. So what we need to do is label where our endpoints should be. So when you have a strong acid titrated with a strong base, you're going to get a curve like this that has this really sharp dip here. So the end point is going to be right here in the middle where the pH is 7. Okay? Now if you have a strong acid and a weak base, your end point is going to be a little bit lower than 7 because the pH of the acid of course is lower, and you're going to have more ionization going on here. Weak acid, strong base, end point is a little bit above 7. And then when you have a weak acid and a weak base, there's a lot of what we call buffer action. So you have a more slopey line. Like there's no big, straight, steep drop off. But the equivalence point is going to be pretty close to 7 for that. So make sure you label all of these arrows and know that those are the end points. Alright, couple of things I just want to talk about. Indicators. These are chemical dyes that change color at a specific pH, and we're going to see a few of these in class. Now, you can look at them. They look like a little rainbow, and they change colors in different pH ranges, so that's a really neat little graph there. And they're also used in what we call buffers. Now buffers are going to resist changes in the pH, and they're especially useful in your blood. You've got a lot of buffers in your body because you don't want the pH of your blood changing too much. It's slightly basic, so you don't want it to get too acidic, and you don't want it to get even more basic.